See here, anode is zinc and the reference electrode is standard hydrogen electrode. Okay, so draw the circuit diagram. Then after that, okay, from here after finishing, then I'll right. And after finishing, tell. Is nothing but the reduction potential of cathode minus reduction potential of anode. Why it is minus? Because in anode oxidation takes place. Oxidation is inverse of reduction. So if you consider, then I have to put, if I have to put them in the same scale, as I told you, above sea level and below sea level, above sea level is plus and below sea level is minus. So for that oxidation is a reverse of reduction. I have put here negative sign. Because of that is equation I have put. See here. Now, this is the E0 cell is what? 1.1 volt. So I'll write 1.1. This one we know how much it is. It is 0. Because we have already Tuesday only have discussed. I told you what is the uh, standard reduction potential of the hydrogen. It is 0.3. Oh. So now this E0 Zn2 plus. So therefore E0 Zn2 plus Zn is equal to what? Oh, I made a mistake. Sorry, dear. Not a 1.1. I have put the value of galvanic. It is 0.76. Please do the correction. This is the problem of old age. What to do? You should have chosen a young teacher. ये तो मुश्किल कर दिया तुम लोग. 0.76. So it is minus 0.76 volt. My drawing is very bad. Please don't mind. Try to draw it little better, okay? See, when you want to go for cathode, in that case, what you do, we take standard hydrogen electrode as the anode, and the cathode we take of the metal. Say here we are doing for copper, so it will be copper here, and the EMF of the cell is 0.34 volt. So if you put it, you find C here. It is coming as positive. Look, this way we have found out reduction potential of all the elements present in the periodic table. So some of them are coming in negative form and some of them are coming in the positive form, and they are arranged in decreasing order. That is, we start from positive and we go down to negative. Okay, and in the middle, what you find? In the middle, you will find hydrogen is there, whose reduction potential is 0.00 volt. So I have a request now. Please open your electrochemistry chapter, and there you will find on table is there is called Electrochemical Series. Please open the book. Did you open?
Yes, sir.
Did you get that table? A big table, full page table is there. Did you find?
Yes, sir.
You find in your book, they have arranged in decreasing order. On the top, you will find this fluorine is there. And if you come down, then you find hydrogen with 0.00 volt. And at the last, you'll find lithium is there. I think its value is minus, what is the value? It is minus,
3.05 minus 3.05.
yes. And fluorine comes with plus 4 point something. Na? Fluorine on the top, you see. What is the value of fluorine given?
2.87.
Plus 2.87, na?
Yes, sir.
Okay. I can write here. Using
He is what?
tempered hydrogen
हम क्लास कर रहे हैं ना
as
फला करते बसे
the standard reduction potential of different elements were determined. Okay. The arrangement of elements either in decreasing order, either in decreasing or increasing order. Why? You'll find some of the book they made it reverse. They have put the negative on the top of the hydrogen and positive below hydrogen. But if you go by this, actually negative should have come down, but it depends upon the, but both way it is correct. Okay, so because of that I have written either in decreasing or in increasing order. Is known as electrochemical series. It is also known as activity. Some of the books they write activity series. I remember that in ICSE book it is written as activity series. It is correct. Application of electrochemical series. Applications of electrochemical series. One. Relative strengths of oxidizing and reducing it. See, there are so many elements or their ions. They carry out either oxidation or reduction. But all of their oxidation capacity is not same. Some are more, some are less. How to know? That you can know it from their reduction potential value. The elements with positive oxidation state, positive reduction potential are found to oxidize others. And elements with negative reduction potential found to reduce others. Because those with negative reduction potential, they have a tendency to lose electron. And generally, they are being kept as NO. Okay? And those with positive oxidation potential, positive reduction potential, they have a tendency to gain electron. We know that oxidizing agents helps other to lose electron and itself gain it. Now, the question is, so there are so many elements are there. You see in your book, so many elements are there. Their reduction potential is positive, but none of them will have the same value. That is, elements with higher positive reduction potential are stronger oxidizing agent with lower positive reduction potential. Similarly, the elements with more negative reduction potential are stronger reducing agents than lesser negative reduction potential. Okay. So I have given you the note I have written very clearly. Because of that, I'm not writing anything. So I'm telling you the basic thing is that elements with positive reduction potential have a tendency to gain electrons, so they are acting as a oxidizing agent. And elements with negative reduction potential have a tendency to lose electron, so they are acting as a reducing agents. Those with higher negative reduction potential, they are found to be better reducing agent with lesser negative reduction potential. But mind it, so elements, it is not that only positive and negative is going to be no. Elements with negative reduction potential can give electron to any other element whose negative reduction potential is lower, or it can give to an electron to an element with positive oxidation reduction potential. Okay. So let me write the summary. Generally, I write like A. Generally, the elements with positive reduction potentials have a tendency to take electrons. That is, they act as oxidizing agents. B. Elements with higher positive reduction potentials are stronger oxidizing agents with, not with, then lesser negative and too much lesser positive reduction potentials. C. Elements with negative reduction potentials have tendency to lose electrons. That is, they act as reducing agents. Elements with more negative reduction potentials reduces lesser negative or positive reduction potential. So now we have learned from there. That is, one metal can reduce another metal if the reduction potential is more negative. So it is not that only the metal can reduce the non-metals, no, not like this. And even a non-metal also can reduce another non-metal. A non-metal with lower positive reduction potential can reduce a metal with higher positive reduction potential. Calculate EMF of a cell. See, now we have found out the EMF of a cell by constructing a galvanic cell. But if you know the value from the table, in that case you did not make a cell. From there only you can find out. Because why? Because you know EMF is equal to E0 cathode minus E0 anode. So all E0 values in the table, in your table is given. So immediately you can calculate. See. Calculation of EMF of a cell. We know EMF of a cell is E0 cell minus E0 cathode and E0 anode. Now, how to know what is from the table which is E0 cathode? Any cathode which is having higher reduction potential is cathode, and anode is lower. So both of them can be positive, both of them can be negative, or one may be positive and other is negative. See, in a galvanic cell, what did you do? We found zinc is having the value of minus 0.76 volt, and copper has the value of plus 0.34 volt. So which is higher? Copper is higher. So copper is cathode and zinc is anode. Now, when you go for zinc and hydrogen, zinc is 0.76 volt minus 0.76 volt, and hydrogen is 0.00 volt. So which is higher? Obviously, negative is less than that of the 0. So in that case, hydrogen will be the cathode and zinc will be the anode. So we can find out from here. So knowing the values of reduction potential from the electrochemical series, it is easy to determine the EM of a cell theoretically. We did not have to construct any cell. This is the advantage of this. Okay.
Yes, sir.
All right. So example, see here, suppose I did not do. So I have taken a cell like this. Zn S Zn2 plus Cu2 plus Nc. We are being given. You'll find this numerical will be given to you like this. Zn2 plus Zn is minus 76 volt. And E0 Cu2 plus Cu is 34 volt. Which is higher? This is higher. So right now here, E0 cell and E0 cell is equal to what? E0 cathode minus E0 anode. Which is between this, which is higher, this is higher. So I'll write now here E0 Cu2 plus Cu, E0 Zn2 plus Zn. So this is 3.4 volt and minus, what is the value here? 0.76 volt. See now, it is 34 volt plus 0.76 volt. So it is 1.1. Now see, galvanic cell that you initially made, was it not showing 1.1 volt? See here. So these are not fictitious. They are correct.
Finish, sir.
Okay, let me take another cell. What is this? Second, this is the second example. Okay, that day I have already done for you. This copper silver nitrate cell. So here, okay, E0 Cu2 plus Cu is already given. I should not have rubbed it. And it is 0.34 volt and it is E0 Ag plus Ag is 0.80 volt. See, both are positive. This is also positive, this is also positive. Then now, see here. Now, which is cathode? Cathode is always higher. So, here, what will come here? It is Ag plus Ag, and it is Cu2 plus Cu. So, what will be the value now? Value will be 0.80 volt minus 0. See, there is no minus sign is there. So it is 0.80 minus 0.34 volt. Okay, how much it comes? It is 6. And so it is 0.46. So this is the way we can calculate theoretically. Third, predicting feasibility of a galvanic cell. Okay. Suppose you have no idea. You thought, oh, they let it be anode and other will be cathode. So if you have done it correctly, it's going to produce electricity. And if you done it wrong, electricity will not be produced. Why? Because we know that in electrochemical cell, electricity is being produced by a spontaneous redox reaction. So what is the condition for a reaction to be spontaneous? In that case, delta G must be negative. Okay. So right now here, in an electrochemical cell, electricity is produced by a spontaneous redox reaction. A spontaneous process is that whose gives energy it is what delta G is negative. Okay, now we know. So delta G, so we can calculate the Gibbs free energy from the following equation. What is the equation? Delta G is equal to minus NF that we have done in class 11. Delta G is equal to minus NF P0 cell, where N is equal to number of moles of electron. F is equal to 96,500 coulomb. And E0 cell is equal to EMF of the cell. Okay, now see, very interesting. When it can be negative. See here, number of moles of electron can never be negative. This is not a negative quantity. So delta G can be negative only when E0 cell is positive. So what we can write? From the equation above, it is very clear that delta G can be negative only when E0 cell is positive. So I'll show you now.
Done, sir.
Okay. So let us take an example, huh? See, we have already learned from the book that if you put zinc in a cell, it liberates hydrogen. So you thought if zinc can produce, why not copper? So we have put copper in a cell. You wait for your whole life. When your grandson also will not see the hydrogen coming out. Okay. So let me write here copper HCl cell. Okay. So in that case, what is going to happen? This is always, this is always anode. I'll write now here copper is Cu2 plus. Now we have become expert only. You know how to do H plus. Then H2G, and you know that you have to use that. So I'll write now here E0 cell. So this is what? This is cathode. You have to write that cathode. So I'll write now E0 H plus H2 minus E0 Cu2 plus C. See, this value you know it. This is how much? 0.00 volt. And this is how much? 0.34 volt. Okay? So ultimately is what? Minus 0.34 volt. So I'll write now here. Delta G minus NF E0 cell. So it is here how many electrons it has taken? 2. Copper is taken 2. See here. CuS has given you Cu2 plus 2 electron because you are producing hydrogen or not. So it is 2H plus 2 electron will give you hydrogen. You add it, this and this will cancel, so it will be Cus 2H plus aqueous. It will give you Cu2 plus aqueous plus hydrogen. Okay, this is the theory. You have learned all theory. Now see here. This 96,500, what is the value? Minus 0.34. All right. So I will not multiply and do anything. What is this? Whole thing is positive or not? Positive. So this reaction will never occur. So if someone sets it, you will tell, just like I told you, that your grandchildren also will not see evolution of hydrogen. Why? Because you know the value of the reduction potential of copper reduction potential of hydrogen. So, and you know the equation delta G equal to minus NF. Within 1 minute, you will say, unless you don't try, this cell is not going to function. This cell will not work. Don't waste time and money and your resources. So we can predict that which cell is going to produce electricity and which cell is not going to produce electricity from this using this equation. And where from you get this value? You get this value from our electrochemical series. Prediction is this cell will not function. Okay, this cell will not function. And one more prediction, what you can say, that copper can never release hydrogen from acids. Okay, now we'll go for the fourth one.
Done, sir.
Okay. Now, fourth, to predict whether a metal can liberate hydrogen from acid. See, the proof is here only. That is copper can never liberate. Okay. See, it is observed that a metal whose reduction potential is lower than that of hydrogen can only liberate hydrogen. That is not only hydrogen. Any element with lower reduction potential can displace an element with higher reduction potential, because lower reduction potential are reducing agents and higher reduction potential is oxidizing agents. All right. So this the proof is already there. If someone asks, tells you immediately, do it and show you. Any element with lower reduction potential can liberate an element with higher reduction potential from its salt. Why I'm saying salt? Because it should be in ionic state. Therefore, any metal with lower reduction potential no, right, lesser lesser reduction potential of that of hydrogen. What is hydrogen production? E0 H plus H2 is 0.00 can displace hydrogen from gases. Thus, in brief, metals only with negative reduction potential can liberate hydrogen from gases, and those with positive reduction potential example copper, silver, gold, mercury, etc. cannot liberate hydrogen from gases. If you don't believe me, see your electrochemical series. All of them are having positive oxidation potential, which is more than that of hydrogen.
Done, sir.
Okay. Now let us try to know what is the difference between, I will not write down, electrolytic cell and electrochemical cell. Okay, first of all, in electrolytic cell, a non-spontaneous chemical reaction, or non-spontaneous redox reaction is being carried out by the help of electricity. In electrochemical cell, a spontaneous redox reaction generates electricity. Second, electrolytic cell is constructed in only one container. And in electrochemical cell, it is made by two containers joined with a salt bridge and externally connected through a wire. Third, in an electrolytic cell, cathode is negative, anode is positive. In an electrochemical cell, cathode is positive and anode is negative. Okay, so these are the differences. These are the differences. So in electrolytic cell, electrical energy is being converted into chemical energy, and in an electrochemical cell, chemical energy is being converted into an electrical energy. Okay. Now, what is the common between these two? None of the book has written. What is the common thing between electrolytic cell and electrochemical cell? See, please remember. Irrespective of the charge on the electrode, both in electrolytic cell and electrochemical cell, oxidation takes part in anode and reduction takes part in cathode. This is the only similarity you have between these two cells. Okay? Now, we'll come for a very interesting part of electrochemistry. We call it non-stick pressure. N-E-R-N-S. So non-stick pressure. Okay. So among all the students I'm teaching, I think only in army school, only one species is there, Miss Gitanjali Pal. She has done it. Anyone from BSF school? Hello. In my book, the BSF school name is written, but I do not know. Whenever I say someone from BSF school, nobody responds. BSF school? Who are from BSF schools? Hello? Don't keep quiet. I get very angry when I say something and you do not reply. In that case, I told you, suddenly one day I'll stop the tuition. Who is there from BSF school? In last equation, what you do? See, it is not necessary that all the time you have to maintain a strength of the solution as 1 molar. It is not possible. It may be more than that, it may be less than that. Okay? So in that case, if you feel only the electrode is responsible to generate the electricity and there is no role of the electrolytes, then it will be very strange. See, you are taking admission in school. It is your duty to study. It is your duty to appear the exam. And whatever the marks that you get, if you think yours, then it is wrong. Please remember, in your study, there is a great contribution is there from your parents. So you cannot ignore. Similarly, when we construct a electrochemical cell and we dip the electrodes in their respective salts, if you feel that they do not have any contribution, then it will be wrong. So NARST first time has incorporated the concentration of an electrochemical cell. Okay. See, for a general electrode, it may be anyone, any of these electrode, cathode or anode. For a general electrode reduction, we know Mn plus aqueous takes one electron and it becomes a metal. Okay, so for this, the Nernst equation of the above is see, this is not natural logarithm, exponential is logarithm. This is one. Okay, so I'll convert this one into natural logarithm. See here, it is E0 and it is E, because this is at the not an ideal condition. This is the ideal condition. This one, this is the value that we get from electrochemical series. If you multiply this by 2.303, it becomes natural logarithm. It is 2.303 RT NF log MS and MN. This is equation 1. And this is equation 2. Okay, right, up to this much.
Done, sir.
Okay. So now let me write the meaning of all this. EMN plus MS. This is simply called electrode because you can do it in any condition. This one you get from the standard book, from the series. It is called standard electrode tension. Okay, what is R? Universal gas constant. Okay, that you know is equal to what? 8.314 joule T temperature. What is the ideal temperature? It is 298 Kelvin. That is, we know universally accepted room temperature is 25 degrees Celsius or 298 Kelvin. Now, what is N? Number of moles of electrons. So, in this process, how many moles of electrons are lost? Whether it is 1 mole, if value of N is equal to 1, say you the metal ion has taken 1 electron, so N is equal to 1. If it is 2, in case of zinc and copper, we have found it is 2, so it is N value will be equal to 2. Now, F is what? F is 96,500 coulomb. Now, oh sorry, this I have to put in third bracket because there is a constant. Now, what is Mn plus? Molar concentration of ions. And what is this? Molar concentration of
Done, sir.
See, according to equilibrium, we always consider concentration of the solid or pure solid or pure liquid as constant or equal to 1.
Easy for?
The concentration of solid metal as constant or unity means what? 1. The equation 2 becomes what? It will be E Mn plus M is equal to E0 Mn plus S minus 2.303 RT and F log 1 and M plus. This is equation. putting the values of R, T, and F in equation 3, we get E Mn plus Ms is equal to E0 Mn plus Ms 2.303, 8.314, 298, and we do not know. It may be 1, 2, 3. So it is 96,500 log 1 Mn plus what? At 298 Kelvin. So ultimately what we have, you'll find is equal to 0.059 by n log Mn. This is equation F 298. Okay. So this is become equation. So this is the equation at respective electrode. For cathode, you will have one equation, and for anode also you will have one equation. That we'll do on Saturday.
Done, sir.
Bye then. Good night.
Bye, sir.
Thank you, sir.